Assalamualaikum warahmatullahi wabarakatuh. My name is Noor Nazihah binti Badrul Hisham. I am from AP229D4C and today I'm going to present my BSR552 individual assignment, which is post-tension concrete. For introduction, pre-stressed concrete is a type of concrete that is used in construction. Pre-stressed concrete is built by stressing the reinforcement during the construction of concrete. This was done in order to increase span length, to maximize concrete strength, and to produce more economical structure. This pre-stressed concrete is invented by Eugene Freycinet, a skilled craftsman in late 19th century. So basically, we have two types of pre-stressed concrete, which is pre-tension concrete and post-tension concrete. Pre-tension concrete is built by stressing the reinforcement before we pour the concrete into the formwork. The second type of pre-stressed concrete is post-tension concrete. We build the post-tension concrete by stressing the reinforcement after the concrete has hardened. There are three main objectives of this study. The first objective is to understand pre-stressed concrete. Second objective is to differentiate between pre-tension and post-tension concrete. And the last objective is to obtain more information on post-tension concrete characteristics. By definition, post-tension concrete is defined as a type of pre-stressed concrete where the steel cables, whether it is monostrand or multi-strand, are stressed by pulling the steel cable ends through the anchorage while the concrete is hardened. We also need to understand some terms that is used in post-tension terminology for better understanding in this chapter. The first term is wire. Pre-stressing wire is a single unit made of steel. The second term is strands. 2, 3 or 7 wires are wound together to form a pre-stressing strand. The third term is tendon. A group of strands or wires are wound together to form a pre-stressing tendon, while the fourth term is bars. A tendon can be made up of a single steel bar. The diameter of a bar is much larger than a wire. So basically, these different type of reinforcement used in different types of building. For a bigger load that is imposed on that building, we will use a tendon or a bars. There are two main types of post-tensioning. The first type is unbonded system and the second type is bonded system. For unbonded system, tendon is encased in plastic sheeting and the tendons does not bond to the concrete. Force will be transferred by the anchorage only. For bonded system, tendon is installed in ducts that are pumped with grout after stressing. The tendons will bond to the concrete. There are a wide variety of post-tension concrete application in different building structure. Post-tensioning is used for the last decade for different building elements such as slabs, beams, wall, mat foundation, bridge deck, and roof slab. So, the application of post-tension concrete can be divided into two sections, which is for unbonded system and bonded system. Unbonded system use monostrand tendon, and monostrand tendon will be used in slabs in building, beams in the building, parking structure, and slabs on ground. For bonded system, it use multi-strand tendon and it will be used on a heavy-duty structure, a structure which will hold more loadings in a building. For example, in bridge roadway, in cable stay bridge, and heavily loaded beams such as transfer girders and landscape plaza decks. For the planning phase in constructing a post-tension concrete structure, we will outline some construction method to build the structure. The first step is we will cast the concrete. After that, we will put tendons and anchorage block, and after that we will put jack. After putting all the materials, we will apply tension to the tendons. After applying tension to the tendons, we will put wedges, and lastly, we will cut the tendons. Constructing a post-tension concrete has its own standards and guidelines. According to the guidelines produced by Construction Industry Development Board Malaysia (CIDB), it has listed some standards. The standards will be applied through every phase of the construction. For example, condition of tendons and anchorage before the construction is all spacing strand and wires should comply with the specified standards and requirement and be free from rust or any foreign object. During the installation of sheeting, the contractor must check that sheeting is properly secured and protected and free from damage or puncture. During the stressing and grouting process, the contractor must check that all grouting operations of the tendons must be smooth and achieved without need to flush out the first grouting. During the debonding phase, the contractor must make sure that open ends of debond tubes over the debond length of strands are sealed. Constructing a post-tension concrete will give a lot of benefits to the all parties that were involved during the construction. First of all, the owners can reduce financing costs, and they also will have more usable space within the available height limits. As for the contractors, they will have a shorter construction period, and it will be easy for them to install other building services such as electric, air conditioning, and other services for flat slabs. For the architects, it will be easy for them to express their ideas as they have more aesthetic freedom. There are a lot of sustainable considerations that were discussed during the designing phase of constructing a post-tension concrete. Recent advances in pre-stressing industry have promoted the usage of post-tensioning in creating more efficient and sustainable engineering solutions. This can be achieved as less material usage through reducing the slab depth that will create more slender structure. A study has been carried out and it shows that post-tension slab can be designed thinner for the same load and spans, thus will make the total weight of the structure reduce, and this will result in smaller columns, lower seismic loads, and foundation load. The structural analysis result also indicate a 36.9% reduction in concrete volume and 43.4% reduction in steel mass in a post-tension slab structure. During the construction of post-tension concrete structure, we must consider the safety and health regulation for all the workers. First of all, we must create a control area of access. No one is authorized along the entire tendon length except for the experienced personnel. The stressing procedure must not be done during the rainy season. The pre-stressing must be carried out when the concrete have reached proper strength, typically around 3000 psi. For the maintenance work of a post-tension concrete, a post-tension structure is hardly to deteriorate with proper handling and excellent workmanship. For existing structure, the rate of deterioration can be observed through different maintenance action. There are 4 classifications of maintenance action, which is a preventive maintenance, corrective maintenance, observational maintenance, and indirect maintenance. So, for my case study, the post-tension concrete structure is applied in the construction of its floor slab. The name of property for my case study is Vid University, which is a campus university for Vid Valor University. It is located in Amaravati, Andhra Pradesh, and it was built on 2017. A year later, on 2018, it was completed. It was developed by Uttarakhand, and the total area of development area is 200 acres. The building type is educational institution, which is a private type. So, for the construction process of post-tension concrete, firstly, we must set up the formwork. After cutting the formwork according to our desired length, we must place the bottom reinforcement. After placing bottom reinforcement, we must fix the bar chair for post-tension tendon and place all the post-tension tendon according to the layout. After that, we must fix anchorage bustling reinforcement. After that, we must place the top reinforcement, which is wire mesh. After that, we must place the anchorage pocket former and group vent at the slab edge and the slab beam. After that, we must fix the slab edge formwork with pocket former. After fixing the pocket former, we must concrete the slab. Concreting the slab must be done along with the vibrator to make sure the concrete is distributed evenly. After the concrete has hardened, we must remove the slab edge formwork and we also must remove the pocket former. After that, we will place the anchor head and wedge in position. After placing the wedges, the stressing procedure will take place. After this stressing process, we will cut the end of strand. After cutting the end of the strand, we must capping stressing recess with cement mortar. After that, the grouting process will take place. After the grouting process has finished, we will repeat the next floor slab construction with the same step. The challenges that were faced by the contractors during the construction of this post-tension slab, them is exposed to the corrosion threat. The usage of too much steel tendon might expose it to the corrosion risk if the strands are not treated before using it. The second challenges that were faced by the contractor is high-skilled labor need to do the stressing procedure. The stressing procedure cannot be done by unexperienced or unskilled labor. The last challenges that were faced by the contractor is improper handling can cause injuries. So, the rate of injuries can increase if the strands are not being handled properly.